Okay, welcome back for the lecture. And during this lecture, we are going to focus on some of the miscellaneous stuff related to the selection statement. So first, we'll summarize the three types of selection statements that we discussed so far, and we'll take a look at some of the common mistakes that we do when you're writing logical expressions. And also, we'll get one more example related to nested if-else statement, where sometimes you might not be able to use a switch case statement in place of that. Okay, we'll see a scenario like that nature as well. Okay, first let's try to summarize the three different selection statement structures that we talked about so far. Right now, when you're having a selection, then so we know that we are going for a choice. Right, so when you're going for a choice, then so we need to make a comparison to see whether we are going for that particular choice. Right, so then in here, so we do a condition check. If that is true, so we'll be performing certain set of operations, and otherwise we do nothing. So since we have only one way of choice here, so we call it one-way selection. Now one-way selection is realized in C++ using if statement, right? So we have if and the expression, and then we have a set of statements to be executed. So therefore, what we write here is pretty much in this box. All right, so that's the logical statement that gives us either true or false value. Right now, on the other hand, in a two-way selection statement, so once you are done with the comparison, so we have two things to do depending on the evaluation true or false. Right, to capture this type of logic, now we know that we have if-else statement. So we have if, the condition check, and then we have set of things to be performed. Otherwise, so we have another set of things to be performed. Right now, here then again, so we have the if condition check here. If this is true, so whatever inside this box will go here. Whatever inside this box will go to the else part. All right, so that essentially capture the two-way selection statements and its logic. Now when you have a switch case statement, so we will be switching into different cases depending on what we have in here, right? So then switch into, let's say, case 1 here. So that's case 1 represented here. So after done with case 1, so we have the break statement. With the break statement, so we'll be getting out from the case and then execute rest of the program. So this is a pretty nice construct that can accommodate various different choices, out of which we'll select one or more. Right, so those are the three different type of selection statements that is available for us in C++ to make choices. All right, now here are some of the common mistakes that we do, especially when you're writing these logical expressions that perform this type of a comparison. All right, now suppose I want to check if a particular number is equals to 5. Right? If it is exactly equals to 5, I want to perform a certain operation. Right, now when I'm writing it, I need to use this equal sign as a comparison, so that this gives me either true or false value. Right, so sometimes let's say by mistake, so we have forgotten to put the two equal signs, we just put one equal sign. Now even if you put just one equal sign, so compilers will actually compile the code. So when you compile the code, this is not going to generate any error, but at runtime, so this is going to be an error. Right, so here if you notice it, x is 3, but here we are checking if x equals 5. If that is the case, we are going to display the message x is 5, but for this code we get the message x is 5, but we know that x is not 5. Right, so therefore when we are evaluating this, so essentially this will be evaluated to something like this. So it will be something like if x. Right, now the value for the x is going to be 5 with the assignment statement, so therefore this will be if 5. Right, so now we know that 5 is not 0. So since 5 is not 0, so value 5 is actually having Boolean value true. Right, so therefore this will always be true in this scenario. Right, so then that's kind of a common mistake that sometimes people do in writing this comparison statement. So rather than having two equal signs for the comparison, so we can perhaps put one equal sign by mistake, but the compiler will not pick it up, right? So that will give us the runtime error with the incorrect logical expression, all right? So that we need to safeguard against these kind of issues, all right? And the second case is something like this. So usually when we are evaluating these comparison statements, so we can combine multiple comparison statements using either AND logic or the OR logic, right? So in here we have the AND logic in here. Now in an AND logic scenario, so we know that if at least one of the sub expressions is false, the whole thing is going to be false. Now in this case, for example, we have x equals to 5 and then y equals to 5. So we are checking whether if x greater than y and x equals to 5. Now in order for us to get the true value for this particular expression, we need to have both of these sub expressions giving us true, right? However, when we evaluate this, we know that x is not greater than y, so therefore this is false. So since the first expression is already false, there is no point of evaluating this expression because it's going to be false anyway. So then the compiler and the runtime environment so pretty much get rid of this additional computation and then do a short circuit evaluation, we call it, and then come up with the final assessment as false for this expression without evaluating anything else in here, right? So now when we do have this kind of an expression, then if you are doing any updates for other variables in here, those things are not going to happen. So therefore usually in comparison statements, this type of a short circuit evaluation is possible. So then we should not do any updates. For example, so if I say x plus plus equals y 5, assuming that x will be incremented by 1 after this evaluation, so that's not going to happen in here, right? So therefore we should not do something like this in this type of a scenario because a short circuit can happen, right? So however, in this case, for example, so where we have x greater than y, so this is true. So since this is true, in order for us to assess the whole statement, so we have to evaluate the second one also. So x equals 5. So we know that this is false. However, this whole thing will be false now. So however, in order for us to get that evaluation, we have to do both of these evaluations, all right? So this is a case where we cannot do a short circuit, but this case short circuit can happen, right? So same strategy applies for OR logic as well as the combination of AND logic and OR logic as well, okay? So therefore we have to make sure that we have some idea about how this works as well, okay? Now here is another common mistake that we do in writing these comparisons. So suppose I want to check if a number say y is between 1 and 10, right? So then if I draw it in the number line, so suppose we call it y, and it should be 0 here and then 10 here. That means that y has to be greater than or equals to 0, that means this side, and y has to be less than or equals to 0, so that this side right here, okay? Now if I want to check whether a number falls into this boundary, so then I need to do one comparison here to check if y greater than or equals to 0, right? And the other comparison here should be y less than or equals to 10, right? Now in order for me to have a number in between this range, so both of these conditions needs to be true. So therefore I have to have both this and this true. So to put it together, so we can write something like this, right? So in computer programming world, so statement has to get both of these true false values and then get the joint expression, right? But mathematically we know that if we write something like this, that essentially implies that y should be less than or equals to 10 and then greater than or equals to 0. But this expression, if I put it in a if statement, is incorrect, right? So therefore if I write something like this, so that's not correct, right? I need to convert that one into something along this line, so where a proper if else statement can be written, all right? So let's get one more example related to nested if else statement where we cannot use a switch case scenario, right? Now suppose I have a situation where I need to determine the letter grade of students, right? So criteria can be something like this. Okay, so if the grade is greater than 90, greater than or equals to 90, so we are going to give A. And if the grade is between 80 and 90, so we are going to give letter grade B. Okay, and then 70 and 80, so this range, so C, and so on and so forth, right? Now if we have this type of construct, so how do we come up with a logical statement for it? So since we are having these ranges, so it's hard for us to come up with a fixed integer value or a character value to determine these ranges, right? So therefore these ranges needs to be written using a nested if else kind of a scenario, right? So to construct this, I can write something like this: if, let's say, I'm going to call it score greater than or equals to 90, so we are going to give A, right? So otherwise we can check whether the score is between 80 and 90. To do that, then I need to check if score less than 90 and score greater than or equals to 80, right? So I need to do this comparison to make sure that score actually fits into this range. If that is the case, so we can give B for that student, right? If it is also not the case, so then I need to check for this range. So then for that, then so it has to be score less than 80 and score greater than or equals to 70, and so on and so forth, right? Now rest of the ranges 60 and all, so we can kind of write the similar statement. Now in here, so if you notice it, so it will be harder for us to come up with a fixed integer value or a character value to represent these ranges. Now if you have a situation like this, so then we have no option, so we have to use the if else statement, right? So there can be different ways that we can get these ranges converted into fixed integer values to represent those ranges. So some computations can be done beforehand, but in general, so if you have a situation like this where we don't really have a direct fixed number or a character or a boolean value to represent, so then we have to use the nested if else statement. All right, so here is the final assessment for it. So if the total then is greater than or equals to 90, so we can give the grade A. Otherwise, if the total is greater than or equals to 80, so we can give letter grade B. If it is also not the case, we can check if the total is greater than or equal to 70, so C and D, and then finally E. Okay, so converting this statement into switch case can be done, but it's challenging. So I would like you all to try it out and then see how we can convert this one into a switch case statement. So we'll post this answer once you are done with this lecture series of this selection statements. But before that, so I would like all of you to see if you can actually convert this one into a corresponding switch case. But sometimes we have situations where there's no way we can convert these type of ranges into a corresponding switch case. So then we need to start to pretty much regular if else statement. This type of a statement is called a nested if else statement, because if else is inside another if else, and so on and so forth, right? Okay. All right, so it's time for us to then do another checkpointing question and then see if you understood the basic constructs related to the common mistakes and the nested if else statement scenarios.